My name is Yuehua Tony Yu.
My name is Meilin Guo.
My name is Ranganath Tiki.
My major is chemistry.
My major in physics.
I'm a doctoral student majoring in chemical engineering.
I'm from Zhejiang, which is right in the middle between Beijing and Guangzhou.
And I'm from Taipei, Taiwan.
And I'm from New Delhi, India.
My parents are very proud of me, especially for my background. My father is a driver. He works in a construction company. And my mother is a physical worker, and she works in the same company as my father is. I'm very satisfied with my life. I have a very beautiful wife, and I have a very lovely baby. I'm really curious about anything, and whenever, like when I was young, our clock was broken, I was trying to open it, see what's happening inside. My father always encouraged me to persuade in the science, because he thinks science can change people's life.
I'm from a small family. I have two brothers. One is older, one is younger. And my parents always be supportive. Whatever what, I made my choice. And then I think they're open-minded people. So encourage me to do whatever I want to do. I call my parents every week. I don't think they know what I'm doing, but it doesn't matter. I really enjoy that, the process of the problem and solve the problem.
I think it's a challenge, but it's also the fun stuff for me because everything is new. No one done that before.
My father is a professor of chemical engineering at the IIT Delhi. So we always had a academically oriented background. I loved maths, physics, and especially nature, like trying to understand nature through science. My mom was a housewife, and actually she was more encouraging than my dad, in a sense that she kind of believed more in me. I guess my dad had higher expectations, but she was always happy when I won whatever little awards I won in school. The night sky really fascinated me, and always had this curiosity that, why is the world the way it is? I felt that there was this huge hand, by whatever you could call it, that there's a certain harmony in the universe. And I think my education, or whatever I did in my life, was my attempt in trying to understand that harmony.
So my project is about the binary Guanxin gels and its applications in biotechnology and nanotechnology. When I first invented this biological gel, I tried different applications.
He took a gel that he'd made, so it's like Jell-O, put it in the refrigerator, and it turned back into a liquid solution, which is completely counterintuitive.
The nature of this gel pushed me into the nanotechnology and biotechnology. Nanoparticles, they prefer to aggregate, and they are very difficult to handle. Our G gels, we can handle them very good. We can individually suspend them, we can sorting them, we can manipulate them, we can let them align on substrate.
We've been looking at them to separate proteins. We've been looking at them to separate DNA.
In biotechnology, we can conquer the problem of storage. And storage consumes a lot of money, longer shelf time. It will probably revolutionize the industry.
The name of my project is Photonic Nanostructure Impact on Solar Harvesting. My project is design 7-layer coating on the silicon to collect more and wider solar energy into the device and improve the photovoltaic efficiency. Compared to the conventional coating, our design can improve 21% efficiency. I work with the material science department and also ECSC department. This invention can be used on solar panel that people use now to improve the solar energy collection.
This technology is also universally applicable to any solar cells.
I believe solar energy will be the huge impact to the world in the future.
The name of my project is Nanorod Structures for Energy Conversion Applications. My nanostructures basically help in converting one form of energy to another.
And here's an example where a person like me, who's a mechanical engineer, and a person like him, we come together and we're able to solve these problems.
Typically, to create an increased surface area, you have to use lithographic processes, which are multi-step, which are very expensive. But our way of growing these nanorods is very simple and direct. So the main advantage of having these structures is that you get a vastly enhanced surface area. For example, I have grown zinc oxide nanorods, which are used in organic solar cells. So we are converting solar energy to electrical energy. The other example is platinum nanorods, which are used as a catalyst in fuel cells. So hydrogen and oxygen combine in the presence of platinum and you generate electricity out of it. The third ones are actually silicon nanorods, which are used as anodes in lithium-ion batteries. The main problem I'm trying to solve in our research is how can we bring these technologies like solar cell, fuel cells within the grasp of common people.
In the future, I still want to focus on research. I hope someday I can be like a professor or chief scientist in a company.
I'm willing to learn and work harder, and then to always have passion for new stuff.
My dream job is to be a teacher. In a sense, to kind of convey or pass on my passion and what all I've learned in life